Hello, welcome back to By Excellence Tutorials. And this is basically the continuation of the previous video. So if you've not watched the previous video, you have the link actually in the description box of this video. You can find that video. In the first video, we solved or we derived for maximum velocity. And in this video now, we are going to be able to derive for minimum velocity. Yeah, so if this is your first time, this is By Excellence Tutorials. We solve tutorial questions, physics, mathematics. Despite that mathematics, we've not yet started uploading the videos. Yeah, and this was a request from one student for us to help out in solving this question. So if you've not yet subscribed to the YouTube channel, kindly subscribe, and don't forget to click on the notification bell so that you're among the first people to get notified whenever we upload new content. Okay, so this question, I think we've already read the question, and here the only difference is when you are looking at it from friction point of view. Okay, and we don't have to forget that relationship. Let me write the relationship that we found. I think that was equation 3 or equation 4. I think, yeah, I think equation 4 of, no, equation 3 in the first video. It was given by that RG. Okay, so we're going to also use this one. We're going to need this one. Okay, so now let's look at the friction force. Or in what direction is this car going to slide? Okay, in which direction is the car going to slide when we have minimum, okay, minimum velocity? So you can see in the question, we are told to say if a car travels too slow, okay, then it will slip towards the center. Okay, so this car, when there is minimum velocity, it will slip towards the center. And this is the center, remember. Okay, it will slip towards the center like that, meaning the opposing force is friction force. So friction force is going to be in that direction. Okay, I hope you are seeing what I'm doing. Friction force is going to be in that direction. The direction of friction force is that one, since it's going to slide downward, and friction force is the opposing force. Okay, so since friction force is going to be in that direction, we know that that friction force is not, it's not on a straight line. It's not on a straight line. Okay, so it's at an angle. It's at an angle theta. And it's going to have the vertical and also the horizontal components. Okay, so now the horizontal component here, we have friction force cos theta and friction force sine theta in the vertical. So since we've done that, then we can go ahead using Newton's second law of motion into coming up with equations and play with those equations. Okay, and you're going to notice a simple difference, and the difference is going to be the signs. The signs we're going to have are the ones that are different. Okay, so Newton's second law of motion in the horizontal, it's giving us that. Okay, so we are going to have in the horizontal, we have two forces. So taking the direction, I'm going to take the direction positive y up, and to the right positive x, like that. All right, so what we have here the net force in the horizontal, we have two forces actually in the horizontal. So the net force will be actually the subtraction, the difference of the horizontal component of the normal force and the horizontal component of the friction force. Okay, because they are in the same as in axis, but they are in opposite direction. Okay, so we are going to have normal force sine theta minus friction force cos theta. This should give us m. So this is the centripetal acceleration that we have. And also friction force, remember the relationship, friction force and normal force is given by that. So we are going to substitute into that equation. And also centripetal acceleration is given by, not V naught. And this velocity is going to be the minimum when we have friction in that direction. Minimum over R, like that. So let's substitute that. We're going to have normal force sine theta minus that is equal to mv squared over R. Okay, so let me even factor out the normal force in advance, because I know that we'll need something like that. It's going to be equal to sine theta minus, normal force has been factored out, cos theta m mean squared over R. So let that be my equation 1 from here. So we go to the vertical. Vertical, we can see we don't have motion, so the net force be equal to 0. So what's the net force? So in the vertical, we have the vertical component of the normal force plus we have vertical component of the friction force, and this minus mg, okay, equal to 0, like that. So we substitute also for friction there. We're going to have normal force cos theta plus is normal force sine theta equal to mg. So making normal force the subject of the formula, we're going to have normal force is equal to mg over cos theta plus mu s sine theta. Okay, so substituting this equation into equation 1 here, we are going to have something like this: normal force cos theta plus mu s sine theta, okay, multiplying by sine theta minus mu s cos theta equal to mv minimum squared over R. Okay. Okay, so that is what we have. So now we might create space. So what we have, we have this equation. So we're going to have the mass and m going like that, and then we can multiply r throughout. So we're going to have v mean squared is equal to rg sine theta minus s cos theta over cos theta plus nu s sine theta. So that is what we have. And we're going to do the same manipulation where we are saying we factor out sine here, sine theta, and here we factor out cos theta. So what we're going to remain with is 1 minus s cos theta over sine theta. Then over here, we're going to have 1 plus nu s sine theta over cos theta. Okay. So here we're going to have minimum velocity being equal to rg tan theta 1 minus nu s over tan theta over 1 plus nu s tan theta. Okay, so remember the equation that I've put there in the first, or that was derived. We had tan theta being equal to v naught squared over rg. So we are substituting wherever there is tan theta with v naught squared over rg. So what we're going to have is v mean squared is going to be rg times v naught squared over rg. And then here we have 1 minus mu s divided by v naught squared over rg over 1 plus mu s times v naught squared over rg. So that is what we're going to have. Okay, so we continue just playing with these. V mean squared is going to be that, and that will cancel. So we have v naught squared, and then we're multiplying by 1 minus mu s rg over v naught squared over 1 plus mu s v naught squared over rg. So we square both sides, and then we're going to have v mean equal to v naught squared 1 minus mu rg over v naught squared over 1 plus mu s v naught squared over rg. So since that is v naught inside there is squared, we can get it out. The square root of v squared is actually b. So we are going to have v naught And then we have the square root 1 minus mu SRG over V naught squared over R. Hence shown. So this is how you go about this question. I know it was like a tricky question, a kind of tricky question, but this is how you do it. And if you are looking for a tutor to tutor you in mathematics, in physics, in chemistry, do contact us on the details in the description box, or better still, you can visit us on our website www.byexcellencetutorials.com, and also you can like and follow us on Facebook at By Excellence Tutorials page, and you never go wrong. Thank you for watching.